minut. Dwa lata czekaliśmy i minutę, nie może teraz. Okay. Okay, so it's 11 o'clock sharp. So ladies and gentlemen, it is my really great pleasure to welcome all the participants of the three-day Polish Scientific Networks Conference 2022, Climate Change, Science and Society. I welcome all the eminent guests from all over the country and our distinguished speakers from USA, Sweden, Netherlands, Austria, Spain, United Kingdom, Norway, Italy, France, Germany, and Poland. I welcome all the audience online, also from our partners, universities from the Arcus networks. Hello, hopefully the connection and the streaming is running well. It's my pleasure to welcome the rector of the University of Wrocław, Professor Robert Olkiewicz, the vice rector of the university, Professor Patrycja Matusz, the vice president of Polish Academy of Sciences, Professor Paweł Rowiński, the president of Polish Young Academy, Jacek Koranowski, the chair of the Association of the Foundation for Polish Science Scholars, Professor Sebastian Mackowski, and the chair of the advisory panel on the climate crisis at the Polish Academy of Sciences, Professor Szymon Malinowski. As you all know, my name is Matt Strzelecki and I'm currently the head of the Alfred Jahn Cold Regions Research Center at the Institute of Geography and Regional Development of the University of Wrocław. And almost 3 years ago, together with my colleagues from the Polish Young Academy and the Association of the Foundation for Polish Science Scholars, we took the initiative and planned this event. And the conference was very generously supported by the Ministry of Education and Science through the Doskonała Nauka initiative. Also, we received support from the Polish Academy of Sciences and from the Foundation for Polish Science. So I'm very, very pleased that after so many troubles, as you know, including 2 postponements of the event due to the pandemic and later on due to the start of the brutal war in Ukraine, now we are here all together to discuss one of the biggest challenges we face today, namely the climate changes, which, as we all know, play a major role in the functioning of the modern world. We are aware that the currently observed changes in the climate system not only rapidly transform world's landscapes and environments, but also affects our economies, our cultures, and modifies our lifestyles and political agendas. The philosophy of this particular meeting, this conference, was to unite researchers and scientists and academics from all the disciplines. And if you followed the conference program, you see that we'll have a chance to listen to the lectures and talks given by the earth scientists, but also biologists, ecologists, oceanographers. But we will also learn about the diversity of approaches and questions important in climate research conducted by our friends from social sciences, humanities, engineers. We'll also listen to the voice of the psychological and medical scientists studying how shifts in climate may influence our health and mental state. And finally, our plan is that we will experience how the climate crisis was translated into the language of art during the planned concert and the visual art exhibition later on this week. And during the conference, a number of you will have a chance to talk and maybe have an interview with the professional journalists and writers. I have to admit that to some extent, this event is an experiment in which we will not only be able to learn about our research results, but also, hopefully, we'll learn how to better communicate across the disciplines and together find paths to better understand processes driving climate changes, but also find solutions how to reduce or how to tackle the climate change risks. And I have to also admit that my dream was to open this conference here in Leopoldina Hall, Aula Leopoldina, the space which is filled with scholarship and the search for truth since centuries. And I thought it would be maybe a little bit bizarre, but also intriguing to start the discussion about the climate system and climate change with such a background. So above us, we will see the apotheosis of the divine wisdom, and just behind us, close to the music gallery, we see the apotheosis of the earthly wisdom. And I hope that now it's our task and our duty to fill this space with the climatic wisdom. And I hope also that this three-day conference will help us to expand our horizons and maybe, and that's also another dream, become a starting point for cyclic meetings. So now it's my honor and pleasure to ask our rector, Professor Robert Olkiewicz, to open a conference and welcome you also at the University of Wrocław.
Thank you very much. Ladies and gentlemen, I would like to welcome all participants of the 5th edition of the Polish Scientific Network's conference entitled Climate Change, Science and Society. Everyone agrees that climate changes are one of the biggest challenges we face today. Extreme weather events like catastrophic flood in Pakistan or drought in Somalia are the most transparent phenomena. But there are also processes which go slowly but inevitably. Melting of glaciers, rising sea levels, warming of oceans are typical examples. Some scientists in Poland say that in the near future we will eat shrimps instead of coats. Without any doubt, such changes have an impact on our societies and everyday life. Therefore, it is so important to analyze these phenomena, to identify the reasons, and to propose solutions. University of Wrocław pays a great attention to that subject. It's worth mentioning that together with Akademia Górniczo-Hutnicza in Krakow and Szkoła Główna Handlowa in Warsaw, we offer studies called Academy of Climate. Ladies and gentlemen, I wish you a fruitful discussion and also a nice stay in beautiful academic city of Wrocław. Thank you.
Thank you very much, Professor Olkiewicz. And Polish Scientific Network's conferences will not be possible without the support from the Polish Academy of Sciences. And I kindly ask Professor Paweł Rowiński, the president, still vice president of Polish Academy of Sciences, also a hydrologist working on climate changes, to also welcome you here.
Thank you very much. Good morning, ladies and gentlemen, dear colleagues. I am probably one of a few people who have gray hair in this room, so it's extremely exciting that we have so many young people in this beautiful environment and surroundings. So thank you for hosting this conference. So, Mr. Chairman, ladies and gentlemen, I first would like to congratulate you on both the initiative to talk about climate change, which is extremely important for our society, for all human beings, and also for organizing consecutive conferences within this Polish Scientific Network. And I would like to acknowledge the Polish Young Academy, which I treat as a younger brother or sister, I don't know, you can choose, of the Polish Academy of Sciences. But also I would like to acknowledge University of Wrocław and the Association of the Foundation for Polish Science Scholars. I feel, and I am extremely proud that I can say these few introductory words here, I feel that I am in kind of three heads here. One as a Vice President of the Polish Academy of Sciences, which I already did. One is as a researcher. I am a hydrologist, so I deal with the consequences of climate change and consequences which are, especially in Poland, extremely crucial for hydrologic system. And the fact that we deal with droughts, much more often droughts, and extreme floodings, which occur much more often than in the past, and will occur much more often. And we also have, I will say a few words a bit later about water quality. These are probably the consequences that we in Poland experience mostly. And when we add to it everything what's going on the world scale, that we expect huge migrations that we will deal with, I'm sure that this subject is something that we should discuss together. I mentioned that I'm in three heads, so the third head is as a coordinator of the interdisciplinary advisory team working for the president of Polish Academy of Sciences, working on various aspects of climate change. We try to alarm the society, we try to alarm the decision makers on various aspects and various threats which are caused by climate change. The last communication, and I need to mention it about being here in Wrocław, was about the Oder River, which is not a direct consequence of a climate change, but when we think about the future consequences of climate change, we can think of future disasters like this if we don't do anything. And I mentioned this interdisciplinary group working on climate change that our chairman is also a part of, just to show that having experienced scientists together with you, young researchers, we can change our environment, we can make a real change, and we should work together. And I think, like in football team, the experienced players together with these young, energetic people can make a difference, and this is what we should do all together, because climate change is something that we need to face and we will face in the future. I wish you a very fruitful, fantastic debate, energetic debate, and I'm sure it will be like this and have a fantastic meeting. Thank you very much.
We'll now listen to the word given by Mr. Michał Press from Foundation for Polish Science.
Good morning. Thank you for everyone for having me here as a representative of the Foundation for Polish Science. Thank you for the host institution, the University of Warsaw. And let me congratulate you first for the idea and concept of these gatherings with a very appropriate name of Polish scientific networks. This is definitely must have been hard work for the organizers and put this all together quite lots of perseverance and effort. Thanks to that, however, we are able to gather the ideas and engage in discussion on some of the most urgent issues for the society of our time. A response to that challenge of the climate change and fragility of the environment is a vital issue also for us, people concerned with scientific research, for the entire scientific community. Eventually, this is science that will bring about solutions for the problems such as energy crisis and shortage of resources, as well as to secure sustainability of Europe. All disciplines of scientific effort welcomed and included. The results of your scientific effort will also strengthen our place and position on the international stage. This is said, however, in the time when we have been witnessing low public trust in scientific evidence. Later, during the day, I will be able to present news regarding upcoming new programs, funding programs of the Foundation for Polish Science, and hopefully we'll be able to answer any questions you may have on the current development regarding the funds, the structural funds for science allocated to Poland for the next 7 years. Finally, the event like this gives us also time to meet and to reach to each other in a very friendly atmosphere. I look forward to all presentations, to learn, to hear them, and your thoughts today, and congratulate you again. And have a good meeting and discussion.
So this is the 5th edition of the Polish Scientific Networks Conference, and that series of meetings was designed to create a dialogue or networking environment for Polish scientists, and it's run by the Polish Young Academy. So I kindly ask now our president, Jacek Kolanowski, to welcome you here.
So, dear distinguished guests, dear participants, dear all, good morning. Today I speak to you in a little bit different role than usual, meaning as a chair of the Polish Young Academy, and I have a great pleasure and honor to warmly welcome you here to this, as Mateusz said, the 5th conference from the series of conferences Polish Scientific Networks, and today we also heard that the conference is about the climate change and the relationship between the science and society. And this conference is typically a biannual annual event organized by the Polish Young Academy of the Polish Academy of Sciences. And it has been organized by PYA almost from the very beginning, so since 10 years now. Its objectives have always been to address the topics and areas from the interface of science in different sectors. And Polish Scientific Networks has been in fact designed with the aim to provide a platform for inclusive and diverse and interdisciplinary, but also cross-sectors interactions, exchange of ideas, scientific results, but also simply just meetings between different people. And with all of this, it was always with a strong emphasis on the scientific excellence and the early and mid-career researchers. And this is no different also today. And as such, I think that it is safe to say that the Polish scientific networks are actually one of the best representation of the very fabric from which the Polish Young Academy is made of. And I think also it represents greatly the values along which we try to operate every day. And the topics of this year's conference, of course, is particularly relevant as it focuses on the climate change from the diverse perspective of science and society. And I believe that every one of us here, independently of our interests, will find something really relevant during that event. I'm personally really very excited about the whole actually plan and program which has been put together by the organizing committee and also scientific committee of the meetings. And I wanted also to thank all the partners and sponsors for making this event possible. I therefore would like to wish all of you, or maybe I should say us, all of us, many exciting hours of lectures, debates and meetings with people from different backgrounds and from different experience and different expertise. And I would like also to invite you actually to the banquet tomorrow, because we are going to announce during that event also the topic and the place of the next 6th conference from the series of the network of the Polish Scientific Networks. So please enjoy your time here, and I'm looking forward to meeting hopefully many of you individually during the whole event. So thank you so much.
Excellent. I also sent some greetings from the director of the Institute, Professor Mariusz Szymanowski, and our head of department, Professor Henryk Marszałek, who couldn't be with us here, doing some fieldwork related to the climate change, hopefully. So it's now time for our plenary session with 3 very interesting talks. So I'm very delighted to introduce to you our first keynote speaker, Professor Dariusz Jemielniak, Professor of Organization Studies at Koźmiński University, a chair of Minds, Management in Network and Digital Sciences, and also Berkman Center for Internet and Society Fellow at Harvard University. I would say ethnographer of the Internet? Why not? Why not? Dariusz, the floor is yours. I will help you with that.
Much appreciated. Thank you so much. First of all, thanks, Professor Strzelecki, for inviting me here. I really appreciate it. And when I'm in this venue, I have a couple of thoughts. First of all, I mean, wow. Second, when I read all this, one wise sentence comes to my mind. Quid Latina dictum est, altum videtur. Which in regular language says, whatever you say in Latin sounds wise. My second thought is, how the hell are they going to heat it all up in winter? And the third, good we have kneelers, because all we can do now is pray. What I wanted to talk to you a little bit now is climate change, the nihilism online. This is what I study. I have a couple of projects focused on misinformation online specifically.
Excuse me.
God damn it, of course. You should have, come on, in such room, there should be a cross here somewhere, right? Thank God, thank you so much. I try to look directly in the camera, thanks. So I have a couple of projects studying misinformation online. One is about vaccine denialism, another climate change denialism, which brings me here, and a third is botnet detection. And what I'm trying to do with these is I'm trying to apply thick big data to studying online communities. And thick big data is a funny term for something that's pretty intuitive, I think. It's basically assuming that we cannot really just do ethnographic studies to get to the gist of the problem. And we cannot really just do data science. It's best if we combine both, because data science will give us a really very strong overview of the big picture. but the ethnography can give us a much deeper insight in what people think, what people believe. So what I'm going to show to you here, and hopefully maybe we can even have a little bit of a discussion, I'm going to show you just a couple of results from the studies I'm running that are somewhat relevant to climate change. The first thing that I think is quite obvious to all of us is that very few people are actually discussing and disputing climate change, but, well, Anthropocene is disputed. And even if it's disputed by very few, they are very vocal. So if we do a study online, you must have heard this, or you may have heard this, about 65% of misinformation regarding medicine and vaccines, but I think it's relevant here as well, comes from a very small number of accounts. So there's very few people or accounts who are spreading misinformation that is super spreaded later. Second thing is that I think we need to take a deep, hard look on what we think ourselves. When I talk to people oftentimes about misinformation, they say, oh yeah, the flat earthers, Waco's, crazy people. Sure, they are there too. But the thing is that challenging the institutional order of knowledge is something that doesn't start there. It maybe ends there with people who take a gun and go to a pizzeria, as happened in 2016 in the so-called Pizzagate, when some Republican fanatic believed that actually, yeah, Hillary Clinton is having a pedophiliac circle in the basement of a pizza restaurant. So it probably ends there, but it doesn't start there. How many people in this very room, ever, in their lifetime, wanted to lose weight? Liars. If you did, how many of you actually consulted with somebody who is experienced, has years of experience and education in dieting? When you're starting a new sport, how many of you actually go to somebody who is, has education, is a fitness instructor with a proper degree, and consulted, how should I do this, my age, my physical shape, how should I do this? No, we don't do that. We actually ask people, our friends who are, in our view, successful at what you're doing in the sports, in the dieting. That's how diets are so popular. Currently, as you probably have heard, one of the big fads is a meat-only diet. Oh, wow. It takes someone, to propose a meat-only diet this time and age, but nevertheless, it's popular because it's a simple explanation, right? Do this, then that. And I think when we take this hard look at ourselves, we start to understand where this discrepancy between the actual science and the popular beliefs starts. We can, of course, take a little more divisive topics like GMO or nuclear energy. Even among people who are reasonably educated, this could be causing a little bit of a stir, even though the scientific consensus is not all that divisive. So we should not be particularly surprised about the climate change denialism. It's not particularly different than many other scientific topics that are out there. Another thing that I think is particularly disturbing is that there are, sure, even those who are persuaded that it's actually a problem, that it's something we need to do here and deal with here and now, is directing their efforts. This is a nightmare. People want to do the good thing. They are just stupid. They are doing something wrong. That makes it even worse. And I will show you results from a paper just got published, I think, a week ago. What we did, we studied a very simple thing. We studied how do people talk about zero waste. Zero waste is, as you know, a movement that tries to combat the climate catastrophe with various approaches to dealing with waste. And what we looked at was specifically the types of containers. So we wanted to look and analyze both qualitatively and quantitatively how do people react to plastic bottles, glass bottles, metal containers, and so on and so forth. What I think is super striking is that glass has very positive sentiment. People love glass. People think it's awesome that we have glass bottles. Yay, I did something good for the climate. I'm drinking from glass, small, tiny glass bottle. While plastic has a horrible, bad reputation. Obviously, if we go into the life cycle analysis of glass bottles versus plastic bottles, depending on the country, of course, in Poland, in Germany, glass is still a huge problem because it is very heavy to transport. We still rely very heavily on fuel to transport this. It needs to be transported to where people buy it. It needs to be transported back. It needs to be washed with warm water. So it's a disaster. One thing if we could do to make things better, it would be probably to persuade people to use plastic more. It's probably heresy, of course. We should drink tap water. But if, as compared to glass, it's still a little better. So one big challenge that we can see is very obviously communicating to those who are already aware the problem exists what they can do. And all of you remember this plastic straws thing. I think I sympathize. It's nice. People wanted to do something good. But if we look at the big picture, it probably doesn't matter. So we need to also be pragmatic, right? We need to look for areas where some effort can make a tiny dent. It's probably not plastic straws. It's nice that people try. It would be nicer if it mattered. Another thing that I want to show you, and it's not published yet, it's currently in review, and I think it's very disturbing. What we did, we analyzed a little bit over than 11 billion Reddit discussions. So it basically took all internet discussions from Reddit over time and analyzed it just to look at climate change, global warming, and the related terms. Of course, we eliminated terms that were relating to climate, political climate, or climate in a specific game, or so on and so forth. And we were looking bigrams and n-grams of these utterances. What is interesting for our discussion here is that over time, people discuss less about climate change and global warming. This could be a little skewed because Reddit is growing, so the absolute numbers are still growing. The number of discussions about climate change is growing, but the number of discussions about everything else is growing faster. Which means that in the public imaginary, in people's heads, potentially it's a huge problem that people are not thinking about climate change more, they are thinking about it less, while the problem is obviously more and more urgent. From the very same study, a couple of things that I think also are a little puzzling and a little interesting, at least to me. Global warming is perceived much more positively than the climate change. And this is mind-blowing. If you recall, how did climate change come to the discourse? You probably will recall 2002, Frank Lutz, a communication advisor to the Republican Party, to George Bush, and he, as we know from the leaked documents now, he proposed that climate change in their polls that they did sounds much less scary than global warming. So they started a political campaign to change the language to climate change, and they succeeded, actually. If we look a little later, a decade later, the number of discussions about climate change as compared to global warming is going down, climate change is going up. But, there's a big but here. The first graph shows you that global warming is perceived more positively. So it's the opposite of what the Republicans assumed. My explanation for this phenomenon is such. People who are hardcore deniers are still using global warming as a term. And for them, it's not a problem. Those who see it as a problem started using climate change and climate crisis and a couple of other terms now, and they are referring to climate change much more negatively. So we agreed to change the language. We didn't agree to change the narrative. We still think it's a big problem. The interesting thing here as well is the subjectivity of utterances here. The subjectivity is basically to what extent people are phrasing their sentences in a way that they sound as if they were objective truths, and to what extent they are expressing it in a way that is more modest. So basically, yes, if I say climate change exists, it's an objective statement. If I say I think climate change exists, it's a subjective statement. Here we can see that climate change discourse has much more subjective components than global warming. So people who are using global warming in their sentences are very authoritative, say, this is a fact, this is a thing. People who are speaking about the climate change are much more honest. They're saying, I think, I believe, this is what in my view, science says, but this is also a warning. This is a warning because if we use subjective language, oftentimes it carries much less weight. And we know this from other studies. Successful misinformers, super spreaders of misinformation will very often use a very authoritative language. They will speak the absolute truth to the general audience. From yet another study of about 40 million tweets and 4 million users, we studied people who are deniers and then who admit that climate change is a problem. So green color here indicates the climate change believers community, red is the deniers, and this is the most important parts. The rest is a little less important. What you can see in this picture is that deniers have a much more negative sentiment in what they're saying. And it doesn't matter what the numbers say. I don't care about these much. What I care is that it's such a big difference. If you're questioning climate change discourse, you're more and more using different language, you're phrasing it differently, you're using even different sources. In another study that I did on #AstraZeneca, I showed that people who are questioning vaccine programs are using entirely different media sources than those who are in favor of vaccines. Here, we have not analyzed media sources yet, but we can see this phenomenon happening already as well, that deniers and people who believe in science are growingly different populations. And in the final slide that I want to show you is that from the same study of about 40 million tweets, is the echo chambers are a thing, and they're growing. There were studies, as some of you know, that show that echo chambers is a disputable phenomenon. And maybe it is, but in this particular data set, I can see it very clearly. People who are discussing climate change from the positions of #ClimateHoax, for example. So those who are challenging the scientific status quo are not even listening to the others. They are using different references, they have different gurus, different influencers, different so-called norm entrepreneurs. So if you think about how to reach them, most likely you will not. Most likely your modus operandi will not be sufficient. So what I want to conclude with, and maybe open it for a very short discussion or questions, we're studying vaccine programs now in Poland. And we started the project before the COVID-19 pandemic started. So we were like lucky, yay, the pandemic. But we were studying the obligatory vaccines. And we were studying to what extent people, especially young parents, to what extent are they reluctant to undergo the obligatory vaccines, measles, and the sorts. What we discovered is that it's not they're all crazy, It's very hard to admit, but they're not all absolute nut jobs. Some of them are just scared. Some of them, unfortunately, hit into the discursive problem of bureaucracy. For instance, when you're When you're having a child, you're going to, into labor, you're requested to sign a number of forms. The reason why you're requested to sign a number of forms when you're going into labor is that it's difficult for the hospital to process all this before you go. It's just a convenience thing. From the point of view of a person who is undergoing this procedure, it's very scary, very annoying. You're agreeing to a number of things you do not have time to consider, which unfortunately undermines trust in the whole system. When you're going to have your kid vaccinated, unfortunately, very few of the doctors and practitioners will have time to explain to you, why do we have such a program like this? Why don't we have exceptions that are much wider? Why don't we have a sliding scale of the time frame for the vaccination? And it's not even the fault of the doctors, right? It's a problem of the system. They don't have time, they don't have procedures, and they don't have proper coaching in how to talk to people who are on the fence with this. But there is a group of people who do have time for them, right? There's quite a number of Facebook groups, TikTokers, Telegram groups, YouTube celebrities who will tell them exactly why they shouldn't vaccinate their kid at all. This is basically filling a specific ecological niche, dealing with a market need, for being listened to, for giving them airtime. The problem is that the needle, which is in the middle, more or less in the beginning, people are not sure, very quickly can go to one side. We just need to push a little bit. And since we are not pushing it the other way, it's being pushed elsewhere. So my conclusion here is, especially with climate change denialists, we need to look for ways to address these specific echo chambers. Not just not publish something in the mainstream media, not publish academic papers. Nobody cares, they don't know. We need to identify influencers and gurus and super spreaders of information there. Maybe we need to come up with our own memes. One thing that I love is if you encounter a very hardcore anti-vaxxer, you should tell them, you know what, you're right. Vaccinations could be dangerous, but you know what? Take homeopathy and it'll be fine. A win-win, right? I mean, it's just pricey sugar. And if they go get vaccinated, it's a small price to pay. I'm kidding, of course, but nevertheless, we need to look for discursive practices that will reach this particular audience. And unfortunately, not very many people want to make the effort to get their hands dirty and understand them, really understand them ethnographically, how on earth they're having these views in their head that we consider absurd, and for them they're only natural. Just one final thought here. In our research of young parents, one thing is super often repeated. A parent telling us, yeah, I know the statistics, but you know what? My kid is special. My kid is 1 in a million, so why should I care about the statistics? It's 1 in a million anyway. This is the thing that we're dealing with. This is the problem and the narrative that we have to be able to address, and I do not really have a good answer how, but I would welcome your feedback or comments, or insults if there's any. Thank you.
Thank you, Professor Emilianiak. Thank you, Darek. I think we have time for at least one question. There was a microphone over there, but maybe Jacek, would you like to use this one?
Thank you so much, Derek, for this, I think, very important and eye-opening talk at the beginning of that conference. And I wanted to actually ask you about what you just addressed at the very end of the talk. So you mentioned about the fact that there are influencers, TikTokers, and whatever, who play, if we want to say, against the scientific evidence or whatever. But we have eco-activists. We have people who are also very influential in this maybe groups of people which we as scientists don't have access to, who seem to have the same objective, or let's say the same belief as we have evidence for, but we rarely work with them. And so my question is, do you see them playing a role, and do you see scientists maybe as a chance to interact with them. And as we provide scientific advice, for example, for politicians, how to do the law about the eco, maybe we should work as scientific advisors to the influencers and eco-activists. Do you think this is a way to go? Or is there any hope in this?
Well, hope dies last. But I mean, I think the problem with this approach, obviously, is that they are preaching to the choir. And who listens to eco-activists, other eco-activists, and regular people? So it's not right among people who are already persuaded. So I don't think it's the way. I think the way is, unfortunately, to understand, acknowledge, and recognize some of the fears that are there, because some of them need to be acknowledged, and we should understand where they're coming from at the very least. And then identifying those who are authorities in their circles, not in our circles. Greta is a great activist, but nobody cares among the people whom we need to persuade. So we need to identify their authorities and deal with them, just like in any marketing campaign, for the matter. Thank you.
Thank you, Dariusz. Okay, so let's move to another talk. So unfortunately, we have a change in the program, just a slight change, because Professor Bogdziewicz did not make way to our conference for reasons beyond his control. Hopefully he can listen to us now, and hopefully, Michał, everything is fine at home. So we have to ask one of our guests to give a keynote speak now in the morning, not in the afternoon. So it's my pleasure to invite now the second speaker, also my friend from Svalbard, Professor Artur Lutz from Utrecht University, a physical geographer. This is very important for me, with a background in glaciology, hydrology, and remote sensing. Artur, this will be your mic. And maybe just a short introduction, Artur, of your research. Artur, your expertise, I think, include hydrological modeling on various scales, ranging from large rivers to small catchments. And I think you are also involved in research and consultancy for the future water in Wageningen, which leads multiple projects on water resources. So welcome here, and again, thank you for accepting the invitation to come to Wrocław.
Yes. Yeah. Great. Thank you, Mateusz, Chair. Thanks for the organizing committee for inviting me also. My name is Artur Lutz, and I'm a researcher in the Mountain Hydrology Group at Utrecht University in the Netherlands. Oh, great, thanks. Yeah, and I will try to give a bit of an overview of the state of the science regarding mountain hydrology and mountain water resources, and how climate change will impact this in the future. Looking at changes in the high mountain water resources, but also at consequences of this downstream. And yeah, it may be a bit weird that someone from the Netherlands living actually below sea level is looking into this, but yeah, strange things happen sometimes, right? Yeah, so in my talk, I'll first give a bit background on the importance of high mountain water resources, then a bit more details about the high mountain water cycle and how that works, and then of course looking at future changes we can expect there. And I'll look mainly at a bit of large-scale studies covering large areas, but you'll see that. And then of course give a few examples of what's done on looking at consequences downstream. So yeah, this is probably familiar to most of you. Everyone who had a bit of a geography classes has seen a figure like this. It's the hydrological cycle as we know it on Earth. And then of course, the mountains are there, at the very top of this water cycle. Yeah, and water from upstream is going to downstream, but it's all very much linked. So the water is generated high up in the mountains, most of it. It goes downstream, where it's also used by us to irrigate crops, to generate hydropower, for example. Water is also used by natural systems, of course, and also in the cities where we live. We also use a lot of fresh water. Yeah, in this water cycle, mountains act as a kind of water towers. This figure from the museum in Solothurn in Switzerland nicely indicates this. Yeah, that is because mountains have much more precipitation than the lower land. So due to orographic effects, the majority of precipitation falls high up there. And they also have a buffering role, because they store water as in glaciers and in snow. And this water can be slowly released during the melt period, like spring and summer. And therefore, they also provide an important buffer during droughts. For example, the drought this year, we also experienced in the Netherlands. Then the Rhine River, which has its source in the Alps, actually most of the water then consists that our country still enters is water that comes from these mountains. So it's very important, also very far downstream, even in my very low-lying country. So maybe that explains also why I'm looking into this as a Dutchman. Yeah, to make this water tower function more clear, with a group of scientists, we developed together with National Geographic an index to indicate this. It's called the Water Tower Index, where we looked on one side at how much water supply is there in these mountains, how much glaciers, snow, surface water, I'll go into this, and how much is the demand in the downstream of these mountains, and how much of that demand needs to be sustained by the mountains, so in case there's a lack of water being generated downstream. Yeah, so we combined that, and yeah, here indicating for this upstream, we looked at how much precipitation falls in the mountains compared to the lowland, how much snow cover is there, how much is the ice volume up there, how much surface lakes, surface water, and on the demand side, looking at how much water is used downstream for irrigation, how much is used for domestic purposes, for industrial, and how much water does nature require. And in that sense, we could analyze this for all river basins on Earth and come up with an index indicating this. So the water tower index value is really high if you have high abundance of water resources in mountains that need to sustain also high demands downstream. And then looking at the global scale, what pops up are of course the river basins in the high mountains of Asia. So the Indus, the Ganges, Brahmaputra, Amu Darya, these are river basins that have a lot of glaciers, a lot of snow, but very arid downstream climate, so not a lot of water generated downstream, and large demands to sustain. But also here in the Andes, there are river basins with high index value, and also in North America and Europe even. If you are interested, this is also all in an online tool on National Geographic, where you can explore all data for all these river basins on Earth. Another study at global scale looked at, in a modeling study, what is now this lowland dependence on mountain water resources. And they show also a bit similar picture, river basins here in South Asia popping up, but also, for example, the Nile Delta, very dependent on mountain water resources, but also very water scarce areas. And zooming a bit into maybe the main use of water, main demand, irrigation, zooming to the South Asian river basins, you see that in this region it's also quite variable. So here you see the Indus River Basin, the Ganges, and the Brahmaputra, and the color scale indicates how much of the discharge consists of glacier melt and snow melt. You see that it's much higher here in the upper Indus compared to the Ganges, where there's much more monsoon rainfall coming, so much more rainfall contributing to flows, whereas here it's largely fed by the glacier systems and snow. And that also translates in where the water comes from that's used for irrigation purposes. You see here the irrigation command areas, and in the Indus basin, it can be more than 60% of the water used for irrigation that would come from glacier and snowmelt. And it's still considerable also in Ganges, where it's in the order of 10-20%, but much less. Then, yeah, that was to indicate how important this water is from the high mountains. Now a bit more into this water cycle and looking at differences in hydrological regimes for different mountain ranges on Earth. So there are atmospheric processes playing a role in the mountains, of course, glacier dynamics and snow processes, and these all influence then also on what the runoff consists of that comes out of it, and the timing of the year of the runoff, for example, and also the totals. We can measure these components in the field, for example. This is from fieldwork in the Himalayas at above 5,000 meters. That can be challenging, of course. Luckily, we also have data from space, remotely sensed data, and ultimately, to say something about the future, we have to put all this data together and use models for our projections. And in the remainder of the talk, I mostly focus on these modeling exercises. So this is a figure showing a bit, this is also the Tibetan Plateau and all the river basins that originate from there, the upstream basins. You see again, for example, the Indus, Ganges, Brahmaputra that I showed earlier, but also the Central Asian basins. And with a modeling study, you can look at what is the source of water for all the rivers. Then again, you see here on the more western basins, there's more glacier melt and snow melt contribution compared to the eastern side, where there's much more rainfall dominated. This is from the same study showing also this in average annual hydrographs, where you see for the western basins in this orange kind of color, which is snowmelt, that snowmelt is a main contributor, and in the eastern side, it's mainly rainfall runoff during the monsoon. And this then also determines, of course, how this discharge is distributed over the year. Where it's more melt-dominated, you get this earlier melt peak towards spring, but in monsoon-dominated basins, most of the flows come in our summer, so the high flow season there. So not all mountain ranges have a similar hydrological regime. It can vary strongly. Then on to the future changes. Of course, there's on one side climate change impact, as we all know, and we'll see more in this conference. Of course, there are changes in climate, temperature changes, precipitation, but also other components, radiation, wind, cloud cover, etc. This all leads to changes in the cryosphere. So changes in glaciers, snowfall, for example, also permafrost. And that ultimately then leads also to changes in hydrology. For example, the total water supplied during a year, but also we can expect seasonal shifts and changes in extreme flows, like floods and droughts. So I'll show a bit of examples on this. First, these are the climate projections, the latest from the 6th assessment report of the IPCC. You see temperature projected to increase. It depends on the scenario how much. And precipitation over land also projected to increase, but as you see, with a much larger uncertainty range than the temperature projections. And important to note is also that mountains, just also like the poles, they tend to warm up faster than other areas due to different feedback systems. For example, the albedo feedback system. When you have less snow cover, then also the albedo changes, which leads to more enhanced warming. But I'm not going into details on that. But yeah, let's have a look at what these climate changes mean for glaciers, for example. This is Everest in 1921, picture taken by George Mallory. Then in 2007, another mountaineer, David Brashears, he moved to the same spot to take the same picture. And what you see there is that the elevation difference in this glacier yeah, it has came down by about 107 meters, which is the elevation of the Dom Tower in my home city of Utrecht. So that's of course a big ice loss. Then looking a bit at the global scale, looking at the differences in elevation taken from digital elevation models, this paper published in 2021 shows for all mountain or all glacier systems on Earth that mass is being lost in the last, let's say, 20 years. So you see that on this scale, so the more red, the more mass loss. Blue indicates yeah, mass gain, but that are only very few areas, so we can conclude overall on the globe, a lot of ice mass is being lost. And in the future this will continue. This is a study, there are multiple studies on this, but I picked just one, on modeling the future of glacier volumes, and it shows that on the global scale, depending on the climate change scenario, we'll lose between 10 and 50% of the total ice mass loss in the next century or this century. So even if we limit global warming to 1.5 degrees, we still face a significant loss of ice. And other plots show this for different regions. There's of course variability between them, but yeah, the trend is quite consistent and clear, I'd say. Now looking at snow, I'm taking only this figure from the in 2019 published special report of the IPCC, special report on oceans and cryosphere, and looking at different regions on Earth. If you look everywhere at the left plot, you see this is the line where you would have no change in snow water equivalent, so the amount of water stored in snow. Everything that's going to the left is negative. So yeah, it's clear if you look at each of these plots, snow cover is receding everywhere. And this is also a regional study for the river basins in high mountain Asia, modeling also these changes in snow water equivalent. And also there, the trend is clear. 1.5 degrees or 2 degrees or even further, snow water equivalent is being lost, and also the discharge that's generated by snow. Then what do these changes mean for ultimately the river flows, what we are interested in downstream? This also a figure from this special report nicely indicates this. So in the top picture, you see on the decadal time scale how this could evolve. You can imagine when glaciers now melt faster, they produce more meltwater actually. But at some point, that amount of ice mass is lost that they start to generate less water. And that's commonly referred to as the peak water. So you have here, you see here on top the glacier meltwater. It increases first until a certain peak and then starts to decline. Notice also that the runoff from rain is increasing because more precipitation falls as rain instead of snow. So you also have less snow melt. Then looking within the year, at the yearly time scale, you also see that at first this glacier melt may increase and snow melt also. Snow melt starts to decrease at some point, and for some catchments at some point you don't have any glacier melt anymore, so then this peak in melt is all gone. It's only just a bit of snow. And during a day, this is to indicate also that if you have more precipitation falling as rain instead of snow, you have a much more rapidly responding system. So you have much more extreme flows, so much more high flows that come from rain, like here. But it depends also, of course, of where you are in a river basin or catchment. The closer you are to the glaciers, the larger this effect is, and the further downstream, it's less. But yeah, in the end, you lose much of this buffering role and get to a much more erratic hydrological system. Then some projections of this that we made. This is, for example, showing how the sources might change in the upper Indus Basin. And you'll see for glacier melt, snow melt, and rainfall runoff, how their contribution could change by the end of the century. So the more towards red is a decline in contribution, and to the other side, it's an increase. And there you see, yes, especially close to the glaciers, you see that glacier melt contribution declines, And it depends a bit if snow melt might decline or increase. Here it increases at the expense of glacier melt. But rainfall runoff, as we see, increases almost everywhere. Then looking at what these changes would mean for total water supply, this is a study we did also for the Upper Indus and Upper Ganges. And we show how the total annuals by the halfway this century could change. So you see here the reference, so the current total runoff, and also how it is distributed over the contributors, and then a projection for the future and also the contributors. And you see that actually we expect increase in flows until halfway the century in the Indus, but also in the Ganges. And in Indus, that would be related to this increase in glacier melt, where the peak of this water will only be reached in the second half of the century. And in the Ganges, which is much more rainfall dominated, we expect this to be because the precipitation is going to increase. So the total amount of water that's going into the system increases. But then, of course, not all of this water can be harnessed. Like in the monsoon season, you have way too much flow, and that's actually where these flows tend to increase then. So seasonal shifts also are important. This is again Upper Indus and Ganges, or the top shows the upstream basin, and this is the total basin. Black line is the current situation, so the current runoff, how it's distributed over the year, and then depending on blue and red are different climate change scenarios. And you see here for the Upper Indus, it's quite clear that the onset of the melt comes earlier, so the flows come earlier in the season, and also they tend to be higher than in the current situation. For Ganges, it's a bit different, so you don't see really this shift, because there's less cryospheric components contributing to the discharge, but its peak gets much higher. Then also these hydrological extremes. So when you have more rainfall instead of snow, you get more rapidly responding systems, so higher flows, and also more droughts because you lose this buffering role. And also you have more extreme rainfall in the future as projected. So this shows then for Upper Indus, Ganges, and Brahmaputra how the change in discharge for a once in 50-year event could change. And then you see that like virtually everywhere in the basin, this change is positive, and it can be, the discharge could be doubled or tripled during such events. And maybe this is what we are already seeing, like the Pakistan floods this year and 10 years ago. The Pakistan floods, the World Weather Attribution Service has even indicated that this is very likely due to climate change. And yeah, I think we can expect many more of these extreme floods in this region in the future. But then, of course, there are also other changes, like the downstream demand. These are global projections for water withdrawals in the future. And it depends on the socioeconomic scenario you pick, but at least until the first half of the century, it's very likely that water withdrawals will increase quite strongly. And the main contributor to this increase is this blue, so the irrigation. Irrigation water demands will surge with the growing population, and we need more food to feed everyone. But then how does this have downstream consequences then? So the change in the demand downstream and the supply from upstream. This is from, again, from the study I showed earlier that looked into the dependence, lowland dependence on mountain water resources, and they project for, let's say, halfway the century. This is for one combination of socioeconomic and climate change scenarios. And you see clearly these hotspots where mountain water gets more, more important. Also here in the Nile Basin again. But yeah, and this is, indicates in particular for food production how important this water gets. So that importance increases. Even if you have maybe changes in this timing and maybe less buffering, the importance increases. And we also showed that for just the river basins in Asia, these are again these flow projections I showed, but if we look downstream at the demand for irrigation, you see that the irrigation demand in the peak of the main cropping season, Kharif, increases quite strongly in Indus, also in Ganges, And also the second cropping season, at the end of the year, the Rabi season, the demand increases. But combining this, so the changes in supply, changes in demand, what does it mean then for the sources of this irrigation water? So we try to look at, again, for Indus and Ganges, what this means for the sources of the water used for irrigation. And what you see in these plots are the changes in water that's coming from groundwater to irrigate, changes in water that's coming from rainfall and base flow, and changes that is coming from in water from glaciers and snowmelt. And what we see for Indus is you clearly see that this earlier melt peak leads to an increase in the importance of meltwater at the onset of that season, so during the month of May. Then in both basins, you see that during the peak of the Kharif season and the onset of the Rabi season, so very critical periods in the agricultural cycle there, the amount of groundwater to complement glacier melt and rainfall runoff is increasing strongly. And that's mainly driven by this increase in downstream water demand. And yeah, our work then indicates also that this would lead to very widespread unsustainable groundwater pumping in a region where already groundwater levels are dropping rapidly. So that could be a big problem, I'd say. Yeah, but that doesn't happen gradually or linearly, this change. In this plot, you'll see how this, for one combination of climate change and socioeconomic scenario, how these sources of irrigation water could change, where you'll see on the y-axis the fraction of meltwater, and on the x-axis the fraction of groundwater. And what happens, at first, not much is changing, actually, so you'll stay up here in this, but then you'll see that the fraction of meltwater goes up until about halfway the century, when then it will start move to the right. So more groundwater is needed, and eventually also the fraction of meltwater is going down again. But how this develops really depends on which climate change and socioeconomic scenario you take. So it's very uncertain how it will develop in reality then, of course. You may have noticed also that the scatter increases, so it means that you get a higher interannual variability also. So you have more years that have stronger reliance on rainfall runoff, but also more years that have a stronger reliance on glacier melt runoff, and more years that have a reliance on groundwater abstraction. So they both become more important to complement rainfall runoff, because you also have higher interannual variability in rainfall. Then a last thing I'd like to show also is that this also has, of course, consequence for hydropower generation. So this is a figure I took from the WWF risk filter, and they show for hydropower locations what could be the possible risk, or what is the most dominant risk. So changes in low flows, so water scarcity, or changes in high flows, these floods. And then it differs strongly over the world. In the Mediterranean, it's really this decline in flows, but in the area where I look at most, it's mostly this increased flood risk that poses risk for hydropower generation. So, but that are I just focused a bit on agriculture and now hydropower. That are just two sectors that would be impacted. Yeah, but there is, of course, much more. And then the key challenge in this, I think, is how to adapt to these changes. Of course, limiting climate change is really important and needs to be done. But as I showed earlier, even when we limit global warming to 1.5 degrees, with this slowly responding glacier system and snow systems, we will face changes. And then also the food systems, energy systems, water, it's all closely, it's all linked. And we have to find ways, pathways, how to look at each of these sectors and find ways to adapt in a balanced way that all these sectors benefit. But that's, of course, a whole different story and beyond the scope of my talk, but we'll probably see more of examples also in the remainder of the conference. Yeah, so thank you very much. That's where I would like to end.
Thank you. We'll start at Karin. So we have a chance for a question or two. Again, from very active president of Polish Young Academy.
Arthur, thank you so much. I wanted to ask you maybe a little bit more on the methodological side of what you've shown. So you've shown us predictions for particular region of the world, which is Himalayas and the Ganges, Indus, mainly rivers and so on. But is the models which you are using, are they transferable to other parts of the world provided we have enough data, or are they built in a specific way to just reflect the predictions specific for that region?
I think I did not understand everything, but you mean a bit how representative this is for, let's say, other regions in the world?
Yes, so you showed us some predictions for a particular region, right? And you've used certain methodology to make these predictions. So is this methodology transferable to other regions of the world easily, or is it the models you've built are specific for that region?
Yes, yeah, well, I mainly focused on South Asia, and there we developed the model for that region, but it can also be applied to other regions, and also others do that in other regions, but not really at this river basin scale yet. But it depends also, of course, on what is important for the particular river basin.
Mm-hmm.
Like these basins have these huge irrigation areas.
Right.
So that's the focus there. But it can, yeah, it can differ.
Can be adapted. Hmm? Thank you.
One of the densest population of the region.
Yeah.
So that's okay. So one more time, thank you, Arthur. And our plenary session will be closed by Natalia Pilgui, early careers researcher from the Department of Climatology and Atmosphere Protection from our university. And Natalia's research concentrates on storms and other extreme atmospheric phenomena.